Hi, my name is Wynn and I'm going to teach you a little bit about differential and integral calculus, logistics, and how it relates to the coronavirus. Differential calculus is used to find what is called the derivative of a function. The derivative of a function f of x is called f prime of x, and it is used to find the slope of the tangent line at any given point on f of x. Since slope is expressed as change in y over change in x, we can also express the derivative of f of x as dy over dx. Derivatives can be found through a variety of tactics, many of which stem from these basic formulae. Integral calculus is basically the opposite. Instead of finding the derivative of f of x, you are finding the equation of which f of x is the derivative. Derivatives and antiderivatives are especially useful in physics because you can take the derivative of a distance equation to find the velocity equation, or take the antiderivative of a velocity equation to find the distance equation. However, physics is not the only application of derivatives and antiderivatives. Another type of differential equation is called a logistics equation, which is expressed as one of these two forms, in which p is population, t is time, k is a constant, and m is what is known as a carrying capacity. A carrying capacity is the number that p will approach as t approaches infinity. The equation shown here is the derivative of p of t, meaning this equation represents the rate of population growth. However, if you take the antiderivative of this equation, then you will get p of t itself. Logistics growth is often characteristic of the population of a species, in which the carrying capacity is the highest population that an ecosystem can sustain. These graphs are great for modeling population of species, but they are also very important right now with the coronavirus. If you look at the graphs of countries like China, Italy, and Germany, where the coronavirus outbreak is pretty much under control, then you will see they follow the graph of a logistics equation almost perfectly. In China, you can see the cases are stabilizing at that M value of about 85,000 cases. However, if you had looked at this same graph several months ago, it would have looked like an exponential equation. And that's terrifying, especially when you don't know about the patterns of logistics equations, because an exponential equation looks like it's just going to keep going and basically take over the world. However, the pattern of logistics for an outbreak actually makes a lot more sense when you think about it. As the number of cases increases, there are more people with the coronavirus, means there are less people that can get infected by it, so eventually the rate will have to stabilize at something at that carrying capacity of m. So even if the news makes the coronavirus seem like this terrifying exponential equation, remember that we've seen in other countries it is a pattern of logistics. So let calculus give you hope that eventually the numbers will stabilize, that carrying capacity does exist. Remember to stay home if you can and practice good sanitation so that we can keep that dp over dt as low as possible. And if you're bored, maybe practice some differential calculus in your free time. Thanks for watching.